The great mechanist philosophers of the early modern era, am I speaking too loudly, or is that okay? Fine? Okay. Including, say, Galileo, Descartes, and Boyle, sought to portray the scholasticism they inherited from the philosophical tradition as excessively wedded to ordinary beliefs about topics like perception. Whereas the scholastics held that the blueness of my jacket is a real property of it, we are told, the modern view is that the particles of the jacket bear various properties such as size and shape and motion that lead a normal perceiver like myself to have a sensation of blue when I see my jacket. They also sought to underscore how neo-Aristotelian notions of causation were tied to outmoded philosophical preoccupations. And so, again, we are told, they rejected 3 of the 4 classical idea from Aristotle, settling just for efficient causation. They then tied these 2 strands of thought together, contending that all change within nature should be understood as involving efficient causal relations between bodies that are characterized by a short list of properties like size, shape, and motion. And for some of the mechanists, like Descartes, this conception of material bodies and their causally relevant properties enables us to conceive of material changes as being susceptible to mathematical analysis. For if we forget about the blueness of my jacket and focus on its size, shape, and motion, then we can think of it as inhabiting the world of geometry. And then the mechanist explanatory project is off and running. Okay. All very obvious and well known. Now, Newton had grown up reading the great modern philosophers like Descartes, Boyle, and Hobbes during his undergraduate years at Trinity College in the early 1660s. And Newton sought to align himself with their generally anti-scholastic, anti-Aristotelian views. He said so in the very first sentence to the first edition of Principia Mathematica, which was published in London in 1687. And that is the first thing on your handout. Let me just read this, although many people will know this very well. The first sentence of the first edition. Since the ancients, according to Pappus, considered mechanics to be of the greatest importance in the investigation of nature and science, and since the moderns, rejecting substantial forms and occult qualities, have undertaken to reduce the phenomena of nature to mathematical laws, it has seemed best in this treatise to concentrate on mathematics as it relates to natural philosophy. And as we know from much earlier scholarship in Newton, this is clearly meant in part as a dig at Descartes, who Newton thought had failed to really use the most sophisticated mathematics in his thinking about natural philosophy in Book 2 of Descartes' Principles. If we allow Newton here a rhetorical nod to ancient wisdom, considering it as a typical flourish of the late Renaissance, we find Newton aligning himself at the very opening of his text with those natural philosophers who wish to reject scholastic principles, replacing them with a mathematical treatment of natural phenomena. Hence, it seemed right from the start that Principia Mathematica would be a welcome addition to the growing panoply of broadly mechanist tracts in natural philosophy near the end of the 17th century. But if a mechanist reader of the Principia were to turn the page, she would have found some confusing elements in the very next part of the text, the definitions. I give here just definition 1, thank you, definition 4, definition 5. There are 8. I don't go through all of them. But let me just talk a little bit about the definitions. The very first definition adopts Cartesian terminology. It concerns the quantitas materiae, the quantity of matter. But unlike Descartes, who thinks of this quantity as the volume of an object, Newton tells us that it should rather be considered as proportional to a body's weight. He says that it would refer to this property as the mass of an object, right there in the comment after the definition. but we do not yet know that it can also be considered as a measure of a body's resistance to acceleration. This does not sound terribly problematic from a mechanist point of view. Similarly, definition 4, which tells us that an impressed force is the action exerted on a body to change its state either of resting or of moving uniformly straight forward, is also not completely alien to the mechanists, for Descartes had spoken long ago of forces in his third law of nature, which again is in part 2 of Descartes' Principles. That was originally published in 1644 and very well known to Newton. If Newton wished to say, for instance, that when a rock strikes another rock, it impresses a force on it, so be it, as long as he sticks with efficient causation, ordinary mechanist properties like size and shape, and contact action. But Newton did not stick with contact action. As we see already with definition 5, Newton tells us that there are various kinds of impressed force, and he gives 3 examples. Is this on your handout? Yeah. Or most of it is. Here are the examples: percussion, pressure, and centripetal force. The first 2 seem innocuous enough for a mechanist. But what does Newton mean by the third? Definition 5, in turn, gives 3 examples of centripetal force: gravity, by which bodies tend toward the Earth's center; magnetism; and whatever force it is that maintains the planetary orbits. Newton's being careful here to use gravity in the more accepted notion, and he isn't yet talking about what he will call later universal gravity. Okay, this presents a problem. It's one thing to say that when 2 rocks collide, they impress forces on each other. It's quite another thing to tell us that something impresses a force on a rock as it falls to the ground, and that something impresses a force on the planets as they revolve around the sun. Are we supposed to think that something impresses a force, say, on Jupiter, which is millions of miles from the surface of the Earth? The notion of force, already in the definitions, has come untethered from its mechanist moorings. We are no longer restricting ourselves to cases that involve impacts between material bodies. We are now employing a causal notion, and remember, Newton defines impressed force as an action exerted on a body, so I take it to be a causal notion from the beginning. We're now employing a causal notion in cases that are not necessarily going to involve impacts at all. So by the end of the first few pages of the Principia, Newton's relationship with the mechanical philosophy has already become vexed, despite that first wonderful opening sentence where he seems to be aligning himself with the mechanical philosophers. Okay, now I'm going to tell you a little bit about how I think, a little bit about how the talk is going to go from here. There's an ironic twist to my story. As I said before, the mechanist sought to portray scholastics as unnecessarily wedded to ordinary ideas about objects, perception, and causation. They replaced this ordinary image of the world, or so we're always told, with a stark, scientific, mathematically precise image of the world. But from Newton's point of view, the mechanists failed to understand that they actually retain a residue of the ordinary image of the world in their conception of causation. After all, why should we think that all natural change occurs through the impacts of material bodies on one another? What convinces us that this is the one causal model for understanding nature? Well, it's ordinary experience, perhaps, that convinces us. Because in our ordinary experience, we cannot, as it were, change the state of something, I won't push this over, but without impacting on it. The reason it sounds outlandish, for example, to say that the sun impresses a force on Jupiter is that this completely deviates from our ordinary ideas about causal interactions. Nothing in ordinary experience suggests that the sun could move Jupiter. The mechanists, despite their best efforts, therefore remain wedded to a picture of causation that emerges from our ordinary experience of material objects and their interactions. From Newton's point of view, we need to continue the mechanist project by jettisoning the last bastion of ordinary beliefs about causation, embracing the possibility that our causal notion, that of a force, can be applied to cases that do not involve impact at all. Newton spent the rest of his career, in my opinion, trying to make this conception intelligible to his critics, interlocutors, and even some of his friends. I describe this dialectic in greater depth in a few minutes. However, before I said there is a double irony, and this gets to the alternative title for my talk. We will see that the double irony is something like this. Just as Newton could portray the mechanists as wedded to ordinary causal beliefs with their fixation on contact action, we will see that Newton himself maintained an allegiance to a traditional metaphysical picture of substances and their actions that was itself wedded to ordinary causal beliefs. Hence, even Newton could not fully escape from the constraints on causal thinking imposed by our ordinary experience of material objects and their interaction. Okay, that's how it's all going to go. Now, I wanted to say one preliminary thing before I get serious. Preliminary thing is the following. Sorry. First of all, Newton never really gives us what we might call an analysis of causation like Hume does, or Kant later. He does not really ask the question, what exactly is a cause? I believe it's actually quite significant that if you look at definition 4, this is at the very beginning of the Principia, for those of you who haven't memorized it yet. Probably not a lot of people have, but before you even start book 1, he says an impressed force is an action. And if you say, well, what do you mean by an action? That's really a primitive. It's not discussed. He's happy to make use of the notion of an action, and then he gets actually quite specific and exact and precise in what he means by different kinds of force and how to measure them later. But in any case, he does not give the kind of analysis of causation you might be expecting in the world after Hume. And not only that, the second point would be also, he does not really try to overcome skeptical questions about our causal reasoning and our causal knowledge in general. Again, that would happen in a post-Humean context. The way I understand some of what Kant does, if anyone's interested, is Kant thinks Newton really gives us the best causal analysis we have of a natural phenomenon in Book 3 of the Principia. But because of Hume's skepticism, let's say in a broad sense, about causal reasoning, Kant has got to confront the questions that Hume raises head on. Newton really doesn't spend any time on skepticism about causal reasoning. Okay, now we're ready to start. The first concept of cause will be the notion of a mechanical cause. That's what I want to start with. Mechanical causes, understood as a species of efficient cause, were all the rage in the 17th century. Roughly, a mechanical cause can be defined as follows. One material object causes another to change its state by impacting on its surface. Classically, when Minnesota Fats hits a billiard ball with a pool stick, it rolls along the table, knocks into a neighboring ball, and makes it sail into the corner pocket. The basic mechanical notion of causation, if it is to be applied to nature, presupposes only that there are material objects in the world bearing our usual list of mechanistically approved properties: size, shape, mobility, and maybe impenetrability or solidity if you read Locke. Newton certainly never denies that there is mechanical causation in nature of this variety. It would be very odd to deny that. However, it isn't quite right to say that Newton endorses the mechanist understanding of mechanical causes. As with other revolutionary figures, Newton accepts very few prevailing notions in his day, including the prevailing mechanist notion of mechanical causation. But you might wonder, could there be a non-mechanist understanding of mechanical causation? What would that be? Well, I think Newton reinterprets mechanical causation And he does so in a way that would make some mechanists a bit uncomfortable. So, Newton's reinterpretation has two aspects. Firstly, he argues that we cannot know a priori, speaking anachronistically, I mean that in the more contemporary sense. We cannot know a priori that mechanical causation is the only variety in nature. Perhaps we could know that empirically, although as it turns out, Newton believes that the evidence points in the other direction, and he will tell us, at least in the case of gravity, that some causation in nature is not mechanical. I'll talk about that in a minute. But secondly, the second aspect of Newton's reinterpretation, Newton contends that we can subsume the fundamental notion of mechanical causation under the more general rubric of impressed force. Hence, as we saw before, he would prefer to say that when the two billiard balls collide, they impress forces on one another. Since force is proportional to mass and acceleration, this gives us a nice measurement of the forces that are impressed. And it gets us away from vague notions of pushing or speeding up or changing motion and so on. Now we're into a realm where we can give a measurement of something. Now, this reinterpretation of mechanical causation already raises some mechanist objections. In order for us to think of this reinterpreted version of mechanism as applying to nature, we must acknowledge not only that there are material objects in the world, characterized by size, shape, motion, and so on. We also need to think of the world as containing forces. Now, some mechanists are okay with that idea, and some are not. However, that isn't the end of the story. Because as you may be aware, saying that there are forces in nature also alters our conception of material objects. To apply the notion of impressed force to objects in nature, we must think of the objects as bearing a quantity of matter that Newton will call mass. Hence, we are now to think of material bodies as bearing a property in virtue of which they resist acceleration. And some mechanists would be uneasy with the idea that we can predicate an essentially dynamical property of material objects. But for now, I'm going to leave that aside. The idea is simply that Newton reinterprets the notion of mechanical causation within a broader dynamical framework. Okay, that's the first concept. That's pretty simple. We're going to get increasingly complicated. The second concept is the concept of centripetal force, or anyway, of impressed forces, but centripetal force would be the one I'm focusing on. As we saw a minute ago, Newton conceives of centripetal forces, such as gravity, as being one species of impressed force. And before he has identified gravity with the force that maintains the planetary orbits, he says that the force maintaining the planetary orbits is also a centripetal force, and therefore a species of impressed force. So before any arguments in the Principia appear, we have the following conceptual view. We can employ our causal notion of an impressed force, and we can apply it to cases in which the causally interacting bodies are spatially separated by millions of miles. So in the definitions, we're committed to the idea that it might be perfectly sensible to say the following. Something impresses a force on Jupiter, thereby maintaining its orbit around the sun. Or when a rock falls from the top of Mount Everest, I'm picturing if you could get to the edge of Everest and it were a sheer plain, you drop it, let's say, and it falls thousands of feet. When that rock falls, something impresses the force of gravity on it, causing it to fall to the ground. Now, in the mechanist interpretation of mechanical causation, this conceptual view really will not do. Newton has inserted that some cases of natural change may not involve contact action between material bodies. After all, if you take our little rock, it seems nothing is hitting the surface of the rock. So a mechanist would insist that if we want there to be anything here more than a mere façon de parler, then we cannot apply a causal notion to the case of free fall. We should reserve any such notion for our eventual mechanist story, according to which, say, streams of particles push the rock toward the ground, or the center of the earth. So the mechanist would say, and in fact did say, that Newton had admitted a kind of non-mechanical causation into his thinking. This leaves open one question, however. What about Newton's reinterpretation of mechanical causation? Is gravity a mechanical cause just in virtue of being an impressed force on the reinterpretation? I think Newton himself answers this question. Now we're going to go to the next part of the handout. I guess it goes to the second page. I think Newton answers this question in a famous passage in the General Scholium. For those of you who don't know, the General Scholium was added to the second edition of the Principia in 1713, and has been the subject of considerable discussion, debate, and so on over the years. I'm going to just read one part of it. And this is my translation, I'm pretty sure. But it doesn't deviate very significantly from Cohen and Whitman, which is kind of the standard. Okay. Here's how Newton answers our question about gravity. Thus far I have explained the phenomena of the heavens and of our sea by the force of gravity. But I have not yet assigned a cause to gravity. We'll get back to that issue of cause of gravity later. Indeed, this force arises from some cause that penetrates as far as the centers of the sun and the planets without any diminution of its power to act, and that acts not in proportion to the quantity of the surfaces of the particles on which it acts, as mechanical causes are wont to do, but in proportion to the quantity of solid matter, and whose action is extended everywhere to immense distances, always decreasing as the squares of the distances. So he gives you what he has said in the law of universal gravitation right there. This is one of the most famous passages in all of Newton. It clearly tells us that gravity is not mechanical because it is proportional to the quantity of matter or mass, and not proportional to the quantity of the surfaces of the particles constituting the bodies in question. It is not proportional to volume. And remember, for Descartes, quantity of matter is a function of volume alone. So this is, again, a way of saying Descartes can't possibly be right if he's going to try to understand gravity. Now, a mechanist would say that gravity is not mechanical because it does not involve impact. But Newton would say that gravity is not mechanical because it is proportional to mass and not to volume or surface area. Newton's view, actually, is epistemically symmetric here. Just as we cannot know a priori that all causation within nature is mechanical, in any sense, he certainly doesn't think we can know a priori that some causation within nature is not mechanical. We have to discover that in Book 3 of the Principia, which is what he's describing here in the General Scholium, by discovering the law of universal gravitation. Now, I hesitate to point this out, but I'll just say one little teeny tiny thing to complicate everything, and then I'll pretend I didn't say that and move on, but just in case people want to talk about it. This indicates that we might have to restate slightly what I said earlier. For Newton, even if we restrict ourselves to impressed forces in the case of an impact, we are still perhaps not dealing with mechanical causation, since all impressed forces are proportional to mass and not to volume or surface area. Of course, a mechanist would take impact to be a sufficient condition for mechanical causation. And if so, then she would disagree with Newton and say that our billiard balls do interact mechanically because there's an impact. It's just that Newton might not want to say that that's mechanical in his special sense that he introduces in the General Scholium. But I'm going to leave that aside because all of the action is really in the case of gravity and not in the case of impacts. Okay, so here's the upshot. According to both a mechanist and a Newtonian criterion, the Principia introduces non-mechanical causation into nature, although they mean different things by that. From a mechanist's point of view, this is forbidden because what Newton has really done is introduce action at a distance into nature. Thinkers such as Leibniz and Huygens pointed this out and objected vociferously. So of course I want to talk about that more. Before we get to that, however, I want to get to my third concept, agents as causes. Now, The first two concepts of causation are complicated enough, but as many of you are aware, Newton does not rest merely with endorsing. He immediately muddies the waters by telling us that he too, like Leibniz et al., rejects action at a distance. But how can that be, you might wonder? Trying to answer this question will end up showing us that Newton actually endorses a third concept of causation, which I'm going to call agent causation. As it turns out, despite his revolutionary work, Newton endorses a very traditional concept of agent causation, one with medieval roots and early modern offshoots. And in fact, it has, according to some people, ancient roots. It may actually go back to some readings of Aristotle's physics, but I'm not going to get into that today. So why do I say Newton too, like Leibniz, rejects action at a distance? Well, let me give you a quotation now. The next thing on your handout, from Newton's letter to Bentley. Let me introduce this briefly. Some of you may know Robert Boyle of the air pump and Boyle's Law fame was an independently wealthy aristocrat who, upon his death, endowed a series of lectures in London, called the Boyle Lectures, which were designed to promote Christianity in some kind of reasonable formulation of it, and in particular to talk about how natural philosophy, as it was developing in the late 17th century in England, actually promoted a reasonable version of Christianity. Very standard kind of thing for many thinkers then. The first person to give the Boyle Lectures was a theologian named Richard Bentley. And as he prepared to give his lectures, Bentley wrote to Newton, essentially saying, I'll paraphrase, you have the coolest theory of anybody in natural philosophy right now. That was supposed to be a joke, but anyway. I'll think of a better joke. So tell me, what does your theory of natural philosophy indicate about atheism or views of matter that lead to atheism and a reasonable formulation of Christianity, etc. So Newton and Bentley exchanged a series of letters, and they're extremely illuminating because they happened in 1692 to 93, after the first edition of Principia had been published, and it was actually at a time when Newton thought of doing a second edition of the Principia, and originally Richard Bentley was going to be the editor of the second edition. That didn't turn out to be the case, and eventually Roger Coates did, many, many years later, publish the second edition. Okay, so here's what Newton says to Bentley. Now keep in mind, Newton is explicitly addressing the question, how should readers in general and the general public understand the theory of gravity? What are the implications of it? What is Newton committing himself to? This is what Newton says. This, by the way, was written in English originally, so this is not a translation. I just changed the spelling. It is inconceivable that inanimate brute matter should, without the mediation of something else, which is not material, operate upon and affect other matter without mutual contact, as it must be if gravitation in the sense of Epicurus be essential and inherent in it. Epicurus, I think here represents the ancient idea of atoms in the void. They have a vacuum and the atoms interact. And this is one reason why I desired you would not ascribe innate gravity to me. That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum, without the mediation of anything else, by and through which their action and force may be conveyed from one to the other, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. It's a reasonably strong sentence. Here's an amazing comment now. Gravity must be caused by an agent acting constantly, certain laws. But whether this agent be material or immaterial, I have left to the consideration of my readers. So there he's bringing back that issue that's also in the general schooling. What is the cause of gravity? Which we're going to talk about. It certainly appears from this letter that Newton rejected the idea of action at a distance between material bodies. He didn't simply say there isn't any, as it turns out. he said it's an absurdity and also inconceivable. Very strong language, I believe, for Newton, who is usually extremely careful not to overstep what he thinks he can really show if you ever challenge him. That was one of his personality quirks, that he didn't like to be challenged, and he always wanted to say things in a very exact way so that if someone did challenge him, which of course did happen a lot after the Principia was published, and even in the early optics papers in the 1670s, he could bring a very forceful reply. So this is an extremely strong statement, and remember, this is not a private letter in the sense that Bentley said, just tell me what you happen to think. This is because Bentley is going to prepare lectures given in London to the public under the name of Robert Boyle, the greatest experimentalist in England in the 17th century, certainly if you don't include Newton, or maybe even if you do. So Newton was speaking to a very wide audience here. Now, Newton does not address the action of immaterial substances here, as this was not relevant for his discussion with Bentley, but he does say that material substances, material bodies, cannot act at a distance. He also insists that gravity must be caused by an agent, which I'm about to discuss in more detail. Now let me just say one thing about the end of the letter. It's sometimes thought that Newton's letter is a bit odd, since he first writes that material bodies require the mediation of something that is not material for them to interact gravitationally. That was the first sentence. And then in the end he writes that he's left the question of whether the agent causing gravity is material open. But that isn't odd. By his readers, he means the readers of the Principia, and not Bentley, the reader of this particular letter. So he's telling Bentley something about what he strongly believes that was left open in the Principia itself. Okay, 6 years after the Principia first appeared, Newton told Bentley that gravity must be caused by an agent acting constantly. But he told Bentley little about that agent. In the General Scholium, however, added to the second edition of the Principia, Newton tells us more about agents. And that's what I want to move on to now. This should be the next thing on the handout. Another famous passage from the General Scholium. I think... How am I on time? Can I read this whole thing? I guess I can. Okay. It is very important. Well, maybe I won't read the whole thing. Every man, I haven't checked the translation, probably every person would be better there, but anyway. Every man, insofar as he a thing that has senses, is one and the same man throughout his lifetime, in each and every organ of his senses. God is one and the same God, always and everywhere. He is omnipresent not only in power, but in substance. For power cannot subsist without substance. That's the key phrase. The original is omnipresens est non per virtutem solum, sed etiam per substantiam. And the key is nam viris sine substantia subsistere non potest. So I have translated that power cannot subsist without substance. In God, or in him, all things are contained and move, but he does not act on them, or they on him. God experiences nothing from the motions of bodies. The bodies feel no resistance from God's omnipresence. What does this very striking passage in the General Scholium to the Principia indicate about Newton's third concept of causation, or agent causation? That's what I want to tell you now. Newton seems to argue in the General Scholium, or suggest, that God's active omnipresence entails God's substantial omnipresence, for action requires substance. This inference calls out for a clarification. Why should a substance be substantially omnipresent just because its action is omnipresent? By action being omnipresent, I mean God can act anywhere in the universe, which, of course, all of Newton's readers would be happy to accept. Certainly, Descartes would have said that, Leibniz. So, if God wants to act on this piece of paper, God can do that. And it could be arbitrarily a different point in space. God could do it anyway. But couldn't we have a substance that is located in one place and that acts somewhere else? After all, this is in the Principia, and Newton just got finished telling us before the General Scholium, which occurs after Book 3, that things like the moon and the earth and Jupiter act on the sun and vice versa, even though they are a great distance away. So he himself gave us a theory in which substances are located in one place, but act on things very far away. It could be arbitrarily far away, for that matter. Hence, there seems to be an invalid inference. From the fact that God's action is located everywhere, it should not follow that God is located everywhere. More specifically, from the fact that God's action is located everywhere, it follows that God's action is located at any arbitrary point P, like right here. But from the fact that God's action is located at P, like God wiggles my hand, it shouldn't follow that God is located at P. Okay, if we are to find an interpretation of Newton's inference that renders it valid, it seems to me we have to take it to have a hidden premise. Namely, a substance cannot act where it is not substantially present. Note, by substantial presence, I mean a substance's location, which we can talk about more if you like. But anyway, if we add this hidden premise, we get a nice argument, and that is here, I think. A substance S acts at point P. A substance cannot act where it is not substantially present or located. Therefore, S is substantially present at P, or located at P. And then you can apply this to God. Since God acts everywhere, unlike all finite material bodies, although gravity makes things complicated, but anyway, God certainly acts everywhere. Therefore, God must be present everywhere by this hidden premise. So according to the third concept of causation, a substance or agent cannot act where it is not. More positively, a substance acts where it is substantially present within space and nowhere else. Newton takes this to be, this is why it's so important that he's talking about God here. Okay? Newton takes this to be a general feature of agent causation because it applies even to God. Since we know that God acts everywhere within infinite space, we must believe that God is substantially present within infinite space. Since it applies to God, we know that Newton's view does not reflect any beliefs he may hold concerning the limitations of finite actors. You might have thought, well, I can only act where I'm present, but that's because I'm a finite being, right, who exists for a limited period of time, and there are many limits on what I can do, maybe because I'm tied to a particular body, so I can't make something move on the other side of the universe, but certainly God could do that. But that isn't the case. God can move something on the other side of the universe, but that's because God is there too. Not because God is doing it from over here, as it were, or from nowhere, for that matter. I should say that part of the background to this view is, I was talking about this before, Henry Moore's correspondence with Descartes. For those of you who haven't read this, I highly recommend it. Unfortunately, it's never been translated, which is a totally bizarre fact. So if you want to become world famous, work on your Latin and translate Henry Moore's correspondence with Descartes, get it published, you'll be world famous. You can give me 5 or 10% of the royalties for suggesting it. Anyway, in this correspondence, Henry Moore, who knew Newton personally, was famous in Cambridge when Newton was an undergraduate, before Newton got there, Moore gets Descartes to make various admissions about the actions of God and how they suggest God's presence within space. I won't go into that, but certainly Newton was very convinced by what Moore had argued, and in addition to other things Moore had written. And Newton thought the proper view of God, to really account for God's action everywhere within space, is to say God is present or located within space everywhere. So he rejects the Cartesian view that God is not located anywhere. Now, of course, we have a problem. How can Newton contend that the sun impresses a force of gravity on the Earth across millions of miles of space, even while contending that action at a distance is inconceivable, and that all substances act only where they are substantially present? How can the sun do something that even God can't do? This is what I regard as the great tension within Newton's causal thinking. Okay, and it leads me to the next section, resolving the tension. I'm going to distinguish in more depth between forces as causes and agents as causes. And hopefully I will convince you that there really isn't a tension after all. Here we go. I want to argue that Newton makes an implicit but actually quite robust distinction between forces as actions or causes on the one, or anything else that doesn't involve the quantity of matter or mass. The presence of those things within the space between the Earth and the Sun is ignored by the law of universal gravitation, and therefore does nothing to interrupt the dynamical relation between the Earth and the Sun. Therefore, to say that there is a distance between the Earth and the Sun is not to assert that there is a vacuum between them. It is merely to claim that they are at what we might call a dynamical distance. If you like, they occupy a dynamical vacuum, for there's nothing massive between their spatially separated centers. As a technical notion, impressed force is intertwined with a technical notion of distance, or so I claim. Now, let's consider the notion of a substance and its action. That's the metaphysical notion. From Newton's point of view, to say that one substance acts on another is to say something that is sensitive to the discovery of a medium between the Earth and the Sun. Take the following example. Suppose there is a non-massive medium between the Earth and the Sun, a non-material medium, because, by the way, mass is essential to matter according to Newton. So when he says not material, it would be not massive. Suppose we discover a non-massive medium between the Earth and the Sun, one that somehow transfers the action of one substance to the other. In that case, it would still be correct to assert that gravity is a distant action, or force, between the Earth and the Sun, because the non-massive medium, as I suggested, is irrelevant for the question of the force. But that's not the case if we're focused on the question of whether one substance acts on another at a distance. For if the immaterial medium between the Earth and the Sun were discovered, it would indicate that the Earth, let's say, transfers its action through the medium to the Sun. Of course, that would mean there is no action at a distance between the Earth and the Sun. Remember that we're dealing with an instantaneous action. If you're wondering, well, how does this medium work? It's instantaneous, and that isn't a problem for anybody. At the end of the 17th century, that becomes a problem later. Another way to put this point borrows some language I introduced a moment ago. In Newton's theory of gravity, we have a dynamical conception of distance, such that two bodies are distant given their spatial separation and the lack of anything massive between them. But in traditional metaphysics, we have an ordinary conception of distance, such that two bodies are distant given their spatial separation alone. The non-massive medium does not disrupt the application of the technical concept of distance because of its dynamical irrelevance, but it does disrupt the application of the second conception. There's another way to distinguish forces as causes and agents as causes. So let me add that now. We know from the metaphysical tradition, and indeed from way back into medieval metaphysics, that each and every action must be attributed to some substance. As Newton himself says, action cannot subsist without substance. You can't have an action, something happens, without some actor that did it. Something's got to do that, according to the metaphysical notion. Now, this is a vague idea, and it gets elaborated in many ways, but that's already enough to distinguish it from impressed forces, especially those of the centripetal variety, like gravity. For Newton argues that his theory does not require us to think, and indeed does not license us to think, that gravity is the property of any body, or of material bodies generally. Let me explain. First of all, Newton certainly thinks that gravity is part of nature. In my favorite line in all of Newton, he says in the General Scholium, "Et satis est quod gravitas revera existat." It is enough that gravity really exists. Secondly, Newton thinks, in addition to that, that gravity is universal. All material bodies gravitate toward one another. He contends, thirdly, that the law of universal gravitation indicates how to measure gravitational interactions. But fourthly, he denies that we have sufficient knowledge to understand gravity through any particular physical model. We don't know whether there's a medium for gravitational interactions, and if so, what properties it might have. So to say that the Earth and Sun interact gravitationally is to say something along the lines I indicated before, but it is not to commit yourself to the idea that they exchange particles or waves, or there's some medium between them, etc. We have no knowledge of what he calls gravity's physical seat. Newton also wishes to deny that any physical interpretation of gravity that entails action at a distance among material bodies, he wishes to deny any physical interpretation of gravity that entails action at a distance among material bodies. So in the letter to Bentley, he says, he wants to deny that gravity is innate, inherent, or essential to matter on the grounds that endorsing that view would commit us to action at a distance. Here's why. If gravity were an essential property, then clearly it would not be dependent on a medium, because you could take it away, it's part of it, and therefore to exist even in the absence of a medium. That would mean material bodies act at a distance on one another. Here we are talking about the actions of substances and not merely of the force itself. But wait a minute, you might say. How can Newton tell us that we can measure gravity using the law of gravitation, even while remaining ignorant of gravity's physical basis? How can we measure anything without knowing what it is physically? I'm going to give you an analogy here that hopefully will help explain this. In the past, and I'm getting close to the end, I know I'm probably almost out of time. In the past history of science, many people were in a position to say that they could measure the temperature, say, of the room without knowing what temperature is. So they could say, for example, with the thermometer, it's, I don't know Celsius, so I'll say something crazy. 25? Is that all right? Okay, 25, it sounds freezing to me, but let's say it's 25. A little bit more? 20. Let's say it's 20 degrees in here. 21 degrees in here right now. That claim that we can measure the temperature wouldn't commit someone to the idea that the air in this room has a particular property, or that there are tiny corpuscles in the air moving in such and such a way, or anything else. You can measure temperature without knowing fundamentally what temperature is. And it took, of course, quite a long time to figure out what temperature amounts to. Newton has a similar situation. He says that we can measure gravity, which is an action, and like temperature, it can cause things. So the temperature in the room could cause you to sweat, presumably. You can make that claim without knowing what temperature is. He tells us we can measure gravity, the interaction of material bodies, without asserting that gravity is a property of anything at all. For Newton, his theory does not license the conclusion that gravity is a property of material bodies, or indeed of anything. That goes beyond our knowledge. Okay, for the conclusion, just a couple more minutes. Let me draw two conclusions from this episode. First, we can conclude, I think, that there is no tension in Newton's views after all. He can have his cake and eat it too. He can simultaneously assert that gravity is a distant action in a technical sense, even while denying that any substance acts at a distance. As the letter to Bentley suggests, Newton thought that some agent must ultimately be responsible for gravity. And he speculated at various points in his career that God might actually be the agent in question. Suppose for a moment that God is the agent. Then according to my interpretation, the following would be the case. Gravity would be a distant action in every case in which two gravitationally interacting bodies are at what I have called a dynamical distance from one another. But no substance would act at a distance, because the actions of all substances that interact gravitationally would be mediated by God, who, as you recall, is substantially omnipresent. Keep in mind, the cool thing about God is God is present not only at the surface of the earth, but throughout the entire earth. That helps understand, well, how could gravity, as he says earlier in the General Scholar, how can gravity go, as it were, right to the center of a body, where the center is what's important about it, and not, well, God can do that. Here's the second conclusion, or it's sort of a philosophical moral of my story. If you like, in his causal reasoning, Newton was a revolutionary physicist, but a conservative metaphysician. As I say, when it came to substances, even the infinite substance, Newton had a very traditional picture of causation that goes way back through the medieval period that really is wedded to ordinary ideas about causation. But the key to future developments in philosophical and scientific understandings of causation is that Newton very deliberately insulated the aspect of natural philosophy that we would call physics, which centers on discovering the forces of nature, from the aspect of natural philosophy that we would call metaphysics, which centers on substances and their actions. Remarkably, this is, I think, the most remarkable thing, Newton insulated physics even from his own fundamental metaphysical preconceptions about how actions must be attributed to substances. That insulation enabled physics in the 18th century to proceed on its merry way, even as it developed concepts and conclusions that greatly challenged the very heart of the metaphysical tradition. Thank you. Oh, however you like. Sure.
Okay, so we're ready for questions. Once you can catch my eye, I will. Yeah. Go ahead.
Thank you. That was very interesting, and I'm completely swayed on that front. I'm just curious what your opinion is about those early writings of Newton, in which I think, perhaps you might say by a parallel kind of argumentation, he opposes the mechanical philosophy. And I'm thinking of the theory of collisions in the Waste book, in which he invokes the existence of what would have been, from a mechanical philosopher's point of view, a completely inadmissible entity, and that's a vis elastica. An entity that you can even operate in perfectly hard bodies, although in other cases it might involve actual finite compression, say of two balls sort of colliding with each other. Without going into the details, his addressing those sorts of problems actually had a very profound effect on the whole notion of impressed force, because the elastic force itself, particularly in hard bodies, doesn't have any sort of kinematic displacement. There's no extensive magnitude applied to it. And indeed, using the impressed force as reflected in the new motion that a body might have after having an elastic force applied to it, gives you, for the first time, a measure of a quantity which is purely intentional. So the irony is that this parallel line of argument says he's ditching the mechanical philosophy, can I say, at the very point of contact, because he's demanding that there be a non-mechanical account of the processes of impact that are central to the mechanical philosophy.
Yeah.
So he has already, by the time he's finished the Waste book, deserted the mechanical philosophy, and long before we get to action at a distance.
Yeah, that's extremely interesting. I hadn't made that connection, and I'm glad you pointed that out. I think you're absolutely right that he was never a completely committed mechanist, although he read Hobbes and Descartes and, of course, Boyle very early when he was an undergraduate at Trinity College in the 1660s. He, I think, was never wedded to their notions of causation. And of course, we were speaking about this earlier today. Depending on when you think he wrote De Gravitatione, this anti-Cartesian tract that was never published during his lifetime, but clearly was written by Newton at some point. Some people think that was quite early, some don't. But he clearly was never a committed Cartesian, which is a non-trivial thing. So what happened with Henry Moore is particularly salient, because Henry Moore was, it seems, a committed Cartesian early in his life. And then he started to have questions about Cartesian mechanism. And he raised these issues in 1648 and 9, right at the end of Descartes' life. It was right before Descartes died. But Henry Moore was much younger. And Moore slowly realized that he needed to avoid thinking in purely mechanist terms or Cartesian terms. And that had a huge impact on many thinkers in England later, including Newton. So Newton had gone to a grammar school where I believe one of the teachers had been Henry Moore's student. He knew about Henry Moore from when he was very young. Anyway, Newton was not like that. He was never a Cartesian, full-blooded Cartesian as far as I know. And I think you're right, you're giving more evidence that he was not a fully committed mechanist even early. He certainly was willing to use the notion of a force in very creative ways, from the mechanist point of view, in very problematic ways, beyond what you were getting in other thinkers. And then, of course, as you say, later with impressed force, he's really completely rejected the mechanist, let's say, strictures on what we could say about causation. I could go on and on about that probably, but I probably should let other people ask questions.
So, Chris?
Yeah, just a clarification right towards the end. I didn't follow the step. If Newton recognized that you weren't going to have action at a distance, why doesn't it follow that distance in your technical sense would require a medium? Because I thought at one point you said he was totally not committed to sort of the metaphysics of it and how things really wasn't an essential property of matter.
Right.
But you know, if we just take the Earth and the Sun, doesn't it follow that? You know, I mean, I like your interpretation that he probably thought it was God that was the substantial medium between them. But why doesn't it sort of follow as a consequence of the view, if you're going to reject action at a distance, that there has to be some medium or other? And you seem to open up the possibility that he wouldn't even say that. And I didn't follow why it doesn't just follow.
I see. Well,
that quote about the Bentley thing about the different kinds of things.
yeah.
Or the thing from.
Well, I think we do need to distinguish between what he says about the force and what he says about substances. So I believe he's committed to the idea that action at a distance between substances is inconceivable,
right,
and an absurdity. So certainly he doesn't want any interpretation of his theory that would entail that must be occurring.
Right.
However, the theory itself is compatible with, that is, what you say about the force is compatible with there being a vacuum.
Okay.
It's just, you see what I'm saying? It doesn't rule out
Right,
one
but
thing or the other.
Yeah, so what I kind of missed was, but it seemed that other considerations required then, so from a physics point of view, action at a distance in a vacuum is completely compatible, but other considerations, namely about substance, would suggest that there still had to be a medium.
Yeah, right. So if you have these two causal notions, one is the notion of a force, and one is the notion of a substance acting, then you have very different questions. With a force, it's perfectly possible that you can apply it to bodies that are in a vacuum. That isn't a problem. And it's also possible that there could be any medium you want, as long as it's dynamically irrelevant. I mean, you know, so people often say to me, well, what is this crazy medium that is not material? And I try to say, well, look, first of all, one has to keep in mind that he is talking about something that doesn't have mass. That's the key. It has no quantity of matter, right? So it doesn't resist acceleration. You can push it all around. And it has no weight toward any other body, if you want to speak kind of loosely. But it could be physical in many other senses. There's plenty of things that might lack those two features. So it isn't necessarily a spooky, kind of crazy idea. It could be physical in many senses of the word physical. It could be things with extension, size, shape, motion, but they lack these two key features. It's still a very puzzling issue. But I think the key is, what does the theory commit you to? What does the application of the notion of a force commit you to? And then, what are you committed to in metaphysics? And I think you can sort of have your cake and eat it too. In that, yeah.
Okay, thanks, that's helpful.
Okay, so I think Ryan was next.
Thank you. I've enjoyed your talk very much. I think I agree with pretty much everything you've said. And I like your resolution of the tension at the end. As you might expect, my comments about the very last conception of cause, what you've called, I believe, agent causation. And comments simply this. Submit a comment for further comment. Why call it agent causation at all? Isn't that just likely to antagonize someone like me, for instance? Why speak of agency in any sense? Why not just stay more squarely agnostic? as Newton does himself, with some other labels. So my point is that one's what might seem like a quibble about words, but maybe something else. Why not adopt a more modern vantage point where we might conceive of the gravitational interaction Newtonian theory in terms of a conditional. It's conditional quality, and furthermore, it's counterfactual quality. It doesn't. So take our Earth-Moon system and say we have a little satellite going around the moon. It doesn't matter if there's actually a satellite there or not, but if there were one, we know there would be an inverse square force such that that satellite around the moon would stand in that interaction with, say, the tip of my pinky.
Right.
Why, I mean, agency, sure we can open the extension of the concept such that it admits it, but why not stay more squarely agnostic?
Well, just to be clear, I'm not sure I understood your question, but if I did, I didn't intend to be using the notion of agent causation to talk about the Earth and the Sun. There we're talking about forces, which I take to be a technical notion, and so we are not dealing with agents or substances at all. Right? We're not in, as it were, a metaphysical context. In a metaphysical context, a material body like the Earth or like me would be a substance, and there's other kinds of substances, right? So, for example, if you're wondering, by the way, about what does Newton think about the mind, you might wonder, given what he said about God, the mind is extended. Henry Moore certainly had the same view. It was because of Newton's dissatisfaction with Cartesian metaphysics, by the way, that he thought you really have to think of the mind as extended. It has to be located in space. Why? Because it acts in space. It acts in a particular place. The mind, I can wiggle my finger. Well, okay, there's got to be a substance that's doing that where it occurs, so my mind has got to be present here. And that's why I can't wiggle something in London. Well, I can in London. I always use London as a faraway place. Paris. I can't wiggle something in Paris. Anyway, because my mind is located here, not in Paris. Leaving that aside, so the agent causation is restricted to the metaphysical context. It isn't employed in what we would call the physics. It's not necessary at all to think about that with forces. Right.
Okay, Henrik and then Bill.
Yeah, thank you very much. I like that a lot. I especially like the distinction you get to towards the end between the physics and the metaphysics. The way I tend so like to see the development of science in this tradition is that it starts with metaphysics, and then physics and metaphysics are very much tied for a long time. And it's interesting that you get to the point of Newton where you get this separation, which I guess is the step of making physics sort of more modern, more contemporary. So that's just a comment. The question I would like to is about agent causation as well. And I was wondering, what does this? I mean, agents causing and God causing as the cause of gravity is. We tend to. I mean, it's natural to think of agent causes as free causes. I don't know what Newton thought about that, but that has implications for how you see, I guess, the necessity of these things. Do you have something? What would you say about that?
Yeah,
of course, it relates to Descartes as well, which has very specific views about that.
Yes, that's an extremely good question, because agent causation does, certainly in this context, imply that it's free cause. But of course, we can take a pen to be a substance. From Newton's point of view, pen is a substance. My mind is a substance. God is a substance. But that wouldn't really apply in the case of a pen. So it might be better just to say substantial action. So we're talking about the actions of substances, whether free or not. Agents, you're right. It restricts it more and it implies something. Here, it's difficult because, although I have not read every word Newton ever wrote, I don't know if anyone has ever done that, because there's so much. As far as I know, however, Newton never really addresses that question about, how do we understand God's relation to the laws, for example. This is, of course, a subject for Descartes, and Newton knows Descartes thinks you derive the first two laws of nature from God's immutability, that sort of thing, and he's perfectly well aware that people have views about God decreeing certain laws to be the case. But as far as I know, he doesn't really give any provide any substantial discussion of God's relation to the laws of motion, such that we could really answer this question. So, Leibniz or Descartes has a long discussion. Leibniz, of course, with possible worlds and the principle of sufficient reason and so on. I don't think Newton has any strongly developed view of, as it were, what the laws of motion tell us about God's sort of choice of the actual world or creation of nature or anything like that. I don't think he has any view. And when he's silent, it's significant because, as I say, he read authors who did address this issue, but he did not want to. Of course, he thought we had an empirical warrant for the laws. We treat them as axioms. Axiomata sive leges motus. A lot of people always forget that. We just call them laws, Well, no, but they're it's also important that he says they're axioms, so we're going to treat them. But what's our warrant for them? Well, it's an empirical warrant. We certainly don't derive them from the property of God, like Descartes. Although, did he actually think, if these are laws, God set it up? Yes. In the Queries to the Optics, he says that, basically. And he says something like, if God had chosen to make things fundamentally different, if he had chosen to make matter different or something like that, we could have different laws. He says that in the Queries. A standard sort of view, but there's no richly developed view like you get in Descartes and Leibniz along those lines. But I think you're right, it would be better to call it substantial action and not agent, or substantial causation and not agent causation for that reason.
So, Bill?
I guess I want to read out the third law of motion here.
Okay.
To any action, there is always an opposite and equal reaction, semicolon. In other words, the actions of two bodies upon each other are always equal and always opposite in direction. So notice it's bodies acting on each other. And the third law of motion, and of course this key step in the argument for universal gravitation, is applying the third law of motion to say the weight of Jupiter toward the Sun and the weight of the Sun towards Jupiter. These are equal and opposite reactions, given Jupiter's orbit and the tiny, whatever we look like it. But the important thing is, it sounds to me like, for your story, the bodies here, first he says their bodies can act on each other.
Oh, yes.
When you're applying the third law of motion, and he definitely applies it to those, as we all know.
Yes.
So they're Jupiter acting on the Sun and the Sun acting on Jupiter.
Yes.
Now, all that is, in your version of it, that's being separated from the substance story.
Exactly.
I like that very much.
Exactly.
That's okay. And so, the sort of thing, there might be so when he's committed to applying the third law in this way, he can claim not to be thereby committed to action at a distance, even though he's using action here.
Exactly.
Okay, and your idea is, they're not being treated as substances in this. The action thing can be separated from the substance thing.
Yes, exactly.
Okay.
Because,
Okay.
or am I interrupting you?
No.
Because, that's exactly it. Because in definition 4, impressed force is the action exerted on the body to change its state. So, and it even says, interestingly, the force consists solely in the action and does not remain in the body after the action has ceased, right? We all know that. So there, and that already is, whoa. So you're really not thinking of that force as a property of the body.
No, it's
right?
okay.
Yeah, it's exerted on it, and it is the action. So forces are not properties in the kind of traditional metaphysical sense. They are actions, but it's a technical notion of action. So everything you said about the third law is exactly right. It doesn't commit him to action at a distance between material bodies. There is an action across space. or an interaction, you can call it. But that doesn't mean that one substance is acting on another. That's a separate notion of action.
Okay, we have a question from Corey, and then we'll go to online.
Okay?
Just a curiosity, really. So the Latin that you provided here, from the general scholium to the colon, it reads down here is sine substantia, etc.
Yeah.
So I guess my question is, why is Venus translated as power there rather than as rather than as force? I mean, is Newton using a different term here than he's used for force all the way through?
Good question. The only reason is, well, force would be vis. The only reason is just to not think he's talking about, impressed forces or something. Vis impressa, yeah. So you can call it that. There are several translations. I forget what Châtelet has. So Emily de Châtelet did the French translation. I have it here somewhere. Don't I?
Yeah,
Oh, yeah.
Here, it's right there at the bottom of the board.
Right before the reconstructed argument.
Oh, but did I do?
It's on the board. It's all over there.
Thank you. Yeah, so hers is, not solely virtually, but substantially. The problem is if you, and I think that's what Andrew Mott had, the first English translator of the Principia, virtually, which meant something different in, the early 18th century than it means to us. We think, oh, virtual, that means it's not real or something. So that's why I didn't say virtually there. But it was just to avoid these kinds of confusions. That's all.
Okay, now we'll go to our virtual questioners.
Virtual questionnaire.
Okay, so this is from Kristen Walsh at the University of Otago in New Zealand.
Okay.
She asks,
Must be late.
how does Newton's non-massive medium fit with his idea of non-resisting ether?
Right. Well, I deliberately avoided the question of the ether. That's a very good question, because that raises all kinds of other issues that were not directly relevant, so I just left it open. And as some people probably know, Newton speculates about whether there is an ether at various times in his life as a medium for various kinds of phenomena. And sometimes it looks like he thinks maybe we can detect an ether, sometimes he thinks we can detect that there isn't an ether. But I didn't want the medium and the ether to be identified, because even if he eventually thinks there definitely is no ether, it's a certain kind of medium, but that would leave open any number of other media, and of course it leaves open God as the ultimate agent underlying causation. So that's the reason to leave it aside. But certainly some of the things he says about the ether, about whether it resists motion, etc., would be relevant for thinking about what kind of medium could he be allowing for the case of gravitational interaction. Hopefully that will be an answer, I don't know.
Is there another?
There is one more online question. Just 1 second here. This is from Joel Brown. Sorry, just a second. So Newton tells us that mass is an ordinary intrinsic feature of material bodies, and this is a property which pertains to resisting change from other bodies, gravity, inertia, etc. It seems rather that mass is not ordinary, but is actually God's acting on God's acting on a body in such that it is attracted to other bodies such that it follows some particular mathematical model. But this doesn't appear to attribute the feature of mass to material bodies. So we'd like you to comment on that.
Well, he definitely attributes mass to material bodies. And he actually tells us in, for example, Rule 3, I think Bill's favorite rule, added to the second edition of the Principia, that mass is an intrinsic feature of a body, and he says it's essential to matter. So it's easy to miss the significance of that, but if we think about what was going on in the 17th century with the mechanical philosophy, if you think about Locke, or Boyle, or Hobbes, or Descartes, or even Galileo earlier. Galileo is a little different, but anyway. It is remarkable that people thought, look, a rock has got a size, okay, it's got a shape, sure. You can't have a rock in my hand in the same place at the same time, so it's impenetrable or solid, depending on which, right? That's about it. Maybe number or something. But Newton says, well, that doesn't matter. He actually thinks the mechanists are not talking about matter. Why? Because matter resists acceleration and will have weight in the appropriate circumstances. So a Lockean body, what Locke calls a solid extended substance, is not material from Newton's point of view. That doesn't mean it's some spooky, crazy thing. It just means, this is how I read it, if you had a Lockean body, if you know what I mean, it's true that you couldn't have two Lockean bodies at the same place at the same time, but if you bumped into one, anything could happen. As long as it resists being in the same place at the same time, it can just accelerate, as it were, arbitrarily, because it doesn't have the quantity of matter. So anyway, Newton thinks that they really don't have matter in their sights. They have something else, something that's not fully material. So Newton certainly thinks mass is essential to matter. The thing about God, it's tricky. He certainly thinks within natural philosophy, when we're doing what I'm calling sort of the technical work of the Principia and forces, we attribute mass to bodies. There's no problem there. We find a way to measure the quantity of matter. That certainly doesn't involve God in any way. If you look at the queries to the optics, I think especially query 31, the last one, there's some speculations there about this very issue. Certainly he thinks God could have made the world to be different than it is. And I think I said this before. He says something like, well, God could have made particles with different properties than the ones that we have in our world. Matter, would it be matter or something else? That's sort of speculative, but there would be different laws. So certainly he thinks ultimately, God did choose to do that, but you certainly are not committed to any particular view about God just by saying bodies have this quantity of matter. That's, I think, not true.
There seemed to be another job that in that question. I mean, this role of mass, the inertia, source of inertia, is clearly for Newton essential. But of course, one of the things that these applications of the third law of motion are allowing is you measure the mass of the sun by looking at orbits about it. And so we can think of that as the active role of mass. And that's the one that requires all this stuff. And the question was kind of, I thought, I hope, that it was talking about both of those things. And I think the story for the first one is, for Newton, clearly that's essential. And the second one, clearly it's not.
Mm-hmm.
Okay, and so I think it's important to
Yes,
separate
yes,
those.
thank you, yeah.
I'm going to abuse my position.
Okay.
So I think there's a sense in which the gap that opens up between the mechanical conception of causation and the conception that's more quantitative and abstract that comes with Newton's conception of force is quite a bit bigger than you suggested. It's not, I agree with you that there's well, I think you agree that there's an important step that Newton makes. I just think he goes a bit further. And I think there's a sense in which it's hard to see how forces, attributing forces, even though he says they're actions, are causal in a kind of direct sense, like the mechanical picture of billiard balls colliding. And these are the sorts of problems that led Russell to say there's no notion of causation in
Right.
physics much later, partly because you have relations of simultaneous relations between quantities specified in equations,
Right.
and it looks like the level at which you can apply something like a mechanical causal notion is more like solutions to the equations describing particular systems as opposed to
Right.
describing them to the forces themselves. So that's just a worry that there's more of a gap that's introduced there.
Yeah.
And so thinking of forces as themselves causes is a little problematic.
Okay. I'm glad you asked that. So we might disagree on that. I don't
Well,
know.
first of all, it's not to deny the reality of forces in the sense that Newton wants to.
Okay, but there's more than that.
Yeah.
That's that Russell paper. I happen to think Russell is not right about what Newton thought he was doing in his physical theory. Now, it may very well be true that later formulations in the 18th and 19th century, you can dispense with this notion of an action. It's some vague idea people have because they bump into things, but forget all that. We're going to do very fancy mathematical physics. We don't need that idea. But I don't think Newton believed that myself. Now, here's two reasons. First of all, because I think he did want to assert what I would call the reality of force in many ways. He certainly thought gravity really exists. That's a very substantial claim, as against, don't forget the, well, not you know this, but I'm saying, in general, the second edition of the Principia, where he rewrote a number of things, added things, was in reaction to all these fundamental criticisms from various mechanists. There was a heavy debate with Leibniz at that time, and he wanted to assert, as against sort of instrumentalist, as it were, to speak anachronistically, reinterpretations of the physics in response to mechanist criticisms, that he was not endorsing that, and he thought gravity really exists. But if you think that's not enough, there's more.
Right. Well, I think we agree. Partly what I would say is the language of causal ascriptions is perhaps not the right way to carry. I mean, it's partly what you mean by cause.
I'm going to borrow this. Is that all right? Let me just say, there's also, leaving that aside, Newton, I'm cheating here, but Newton corresponded with Leibniz directly. Almost nobody really ever writes about that very much because of the Leibniz-Clark correspondence, how important that is.
This is in the 1690s.
1693, exactly. Newton and Leibniz corresponded directly. And let me just tell you what happened. So Leibniz
urges him to speculate, and he doesn't take him up on it.
Well,
No, wait.
no.
It's not.
I'll tell you. Right. Leibniz certainly is not happy with what happens in the Principia with gravity, obviously. He thinks there's a problem. Newton says, however, I just want to see if I can, yeah, here it is. He says, this is Newton writing to Leibniz, 16 October 1693, directly, so not through Clark at all. That was much later. Since all phenomena of the heavens and of the sea follow precisely, so far as I am aware, from nothing but gravity, acting in accordance with the laws described by me, and since nature is very simple, I have myself concluded that all other causes are to be rejected, just gravity, and that the heavens are to be stripped as far as may be of all matter, etc., etc. I am your most sincere friend, and I value your friendship very highly. Farewell. Okay, so I think, so even when writing directly to Leibniz, who had been criticizing him on this exact set of issues, Newton says, gravity is the cause. It acting alone is enough when we're doing, physics, right? This is exactly the same time he's writing to Bentley. So it's not about the metaphysics, it's about the physics. Gravity alone is enough. All other causes should be rejected. I think he's strongly committed to the idea that if you want to know what causes the moon to, orbit the Earth, it's gravity. It's not Leibniz's theory of the vortices, and it's not Descartes' theory, and it's not any other theory. Gravity acting alone does it. So I think it's a strong causal notion, and I think it is an essential feature of what he at least takes himself to be doing, which is compatible with what happens. Later maybe you can. I mean, of course, we can see how it becomes more technical, more abstract, getting further and further away from fundamental notions, maybe. But I don't think he was willing to give up on the notion of a cause, and I think he thinks the force is a cause.
Somewhat talking past one. I mean,
okay.
I'm arguing that the notion of mechanical cause that you said he distances himself from, he goes further.
Right.
And that, I mean, I take him to be saying, as in some of the passages in the General Scholium where he says he doesn't know the cause of gravity. What he means is, in that context, he doesn't have a hypothetical explanation of gravity or an identification of the physical source of gravity.
Right.
So cause is used in a particular sense there.
Exactly.
In the passage to Leibniz, I don't see why you couldn't. I mean, in that sense, he's saying there's no other force that's needed, or perhaps no other cause in the mechanical sense, or that's how you were reading.
Well, he doesn't. That's true. He doesn't.
But in any case, I've abused my position.
Okay.
So please join me in thanking Andrew for a really good talk.